What we're going to talk about now is significant figures. And sig figs are the important measurements, or excuse me, the important digits in a measurement. And we're also going to talk about how this relates to accuracy and precision. And so if you take a look here, I've defined sig figs and accuracy and precision up here in the corner. But accuracy is just how close a measurement is to the actual value of whatever it is that you're measuring. And precision is how close a group of measurements are to each other. So what I've done here is I've drawn two really rudimentary rulers where this top ruler is just marked in the tens places. So it's 10, 20, 30, 40, etc., etc., etc. And this bottom ruler is marked to the ones place. So it's 10, 11, 12, 13, 14, etc., etc., etc. So if you take a look at them, we're going to try and measure this red line. Now pretend that red line is straight, and we're going to use each ruler to measure the red line. So if you ignore the bottom ruler and just look at the top ruler, it is somewhere between 10 and 20. That's all we really know about the red line at this point. So it's bigger than 10 and it's less than 20. Oh, pardon my horrible penmanship there. Let me try that again. Again, it's, like I said, it's X is bigger than 10, whatever the red line is, and less than 20. Okay, that's all we know about it. So right now, what we know for certain is that we know that it's greater than 10. So we know the tens place. We know that for certain. I'm going to underline that to show that that's for certain. What we don't know is anything beyond that. So if we just take a look at where it is, and again, kind of cover up the bottom one, just look at the top one, it looks like it's a little bit less than half. So it's going to be somewhere between 13, 14-ish if you kind of estimate there. So we're going to estimate that. I'm going to estimate it at 14. Okay, I'm going to circle that, and then I'm also going to throw some units on there and say it's in centimeters. All right, so the measurement that we get of that red line from the top ruler is a measurement of 14 centimeters. And this goes in with our measurement rules because you are allowed to write down all of the digits you know and then one digit that you don't know. So if you take a look at our ruler there, what did we know? We knew, again, that it was between 10 and 20. So the digit I was certain about was the tens place. I knew the 1, all right? But what I didn't know was anything beyond that. So I had to estimate, use a best guess, and I guesstimated about a 4, all right? And so the measurement I got there was 14 centimeters. So this measuring device gives us two significant figures. Okay. Now, if we go down and look at the one at the bottom, what do I know for certain? Now, because it is marked to more places, I know things for certain better than I did before. So if you take a look, now I know that it's at least, so here's 10, 11, 12, 13, 14. It's between 13 and 14. So what I know for certain now is that is between 13 and 14. I have more certainty of what that number is. So what I can write down now is, because I know it's 13 at least, I can write down that it's at least 13 point, and now I'm going to guess somewhere between 13 and 14. Again, it looks a little bit less than half between 13 and 14. I'm going to guess 13.3. I'm going to call that centimeters. All right. So again, the things that I knew the 13. I estimated the 3. It gives us a measurement of 13.3 centimeters. Now, what does that have to do with significant figures and accuracy and precision? Well, if you take a look, The top measuring device gave us 2 significant figures. The bottom measuring device gave us 3 significant figures. All right. The top device giving us 14 centimeters and the bottom device giving us 13.3. The top device would be considered less precise than the bottom device. And here's why. Precision is how close a group of measurements are to each other. In other words, another way of saying that is how repeatable it is. If I were to measure the same red line over and over and over and over again, on the top ruler, I would generally get something about 14. Maybe occasionally I would get 13. Maybe occasionally I'd get 15. So really what I have here is I have a range of error of somewhere between 13 and 15 centimeters. That's my measurement that I'm going to get. While that's okay, it's not great. Whereas if I look down at the bottom ruler, I'm always going to get somewhere between 13 and 14. I'm never going to get less than 13. I'm never going to get more than 14. And my range of error here will be somewhere between 13.3, 13.4, maybe 13.2. So measuring the same line over and over and over again on the top ruler, I would get a wider range of possibilities as I would if I measured with the bottom ruler, where I would get a smaller range of possibilities. So therefore, the ruler on the bottom, the one with the smaller increments, is more precise because it is more repeatable. The measurements will be closer to each other because of the fact that it's marked to a smaller degree. Now, if we talk about accuracy, and this is what doesn't make a lot of sense, both rulers are considered to be accurate. If the actual value of a ruler is somewhere between 13 and 14 centimeters, my estimate on the top of 14 centimeters is an accurate measurement. It is actually somewhere between 13 and 14 centimeters. 14 centimeters is accurate. On the bottom, 13.3 is also accurate. It is close to the actual value being between 13 and 14. So the number of increment marks on a ruler does not determine the accuracy of the ruler. However, an ruler with more marks on it will be more precise. So it is a better ruler, but not because it's more accurate, but because it's more repeatable and therefore more precise. And that is how accuracy, precision, and sig figs all tie together with measurement.